catastrophic loss reduction at the University of Western Ontario, but here working with the Simon Fraser University ACT team, Deborah and group, and very pleased to be here and have the opportunity to speak to you. I'll try and go fairly quickly through what I have, leave time for questions, discussion, comments, etc. First of all, I think we need to recognize when we talk about climate, we're really talking about the changing of our weather, from tornadoes, smog, storms, right through to climate change. And as humans, we are affecting the climate through a variety of things, putting greenhouse gases in the atmosphere, but through that it comes back to affect us, people and infrastructure, through the storms, the floods, the smog, those other kind of climatic events. I'm a weather guy by background, so the greenhouse effect is real. Carbon dioxide is the main gas of concern, and I think it's important to recognize that scientifically some of what we call the time scales of this thing. If you put a water molecule in the atmosphere, within roughly 10 days it rains out somewhere, usually over BC in the wintertime. And water vapor is the most important greenhouse gas, but humans are not directly affecting it. It just goes up, rains out. But the other important thing is that the climate system itself takes a long time to respond. It takes years to centuries. If we put CO2 or anything else into the atmosphere, within a few years, 2 to 4 years, it's mixed around the globe. And so water doesn't get mixed around the globe, sulfur dioxide as a local air pollution doesn't get mixed around the globe, but methane gas and carbon dioxide stay in the atmosphere somewhere, in the case of methane, around 110 years, carbon dioxide about 100 years. What that really means is the amount of CO2 we have in the atmosphere above us does in some sense depend on what your great-grandparents did. And it also means that what we do now will affect our grandchildren. And this very slow responding system makes it hard to deal with as a policy sense. Politicians are worried about between now and the next election. I used to be an assistant deputy minister in the federal government, so I heard that many times. I'm not a politician. Anyway, the point is that because CO2 is 100 years in the atmosphere, within a few years it mixes globally. It's a global problem, and we have to think about it in emissions that way. The question of CO2, I think, is not very clear. The amount in the atmosphere has gone from 280, and we're now over 380 parts per million. And that's directly related to fossil fuel consumption. So is the climate changing? The chairman made a comment on this. Well, here's the last 150 years. We can, as a science, we put a straight line through it. It's like that. If you take the last 100 years, it's like that. The last 50 years, the rate of warming is 0.13 degrees C per decade. And for the last 25 years, the rate of warming is 0.18 degrees C per decade. We are accelerating the rate of warming, and in that last 25 years, it is scientifically very concluded that warming of the climate system is unequivocal. We're seeing it in the oceans, the atmosphere, the lakes, the ice, the snow. And just so you know, 2007 looks like it may be probably the second warmest year after, say, 2005. So we're seeing succession of warm years. And the scientific conclusion is that the greenhouse gas emissions from human activities are the main cause of this warming. And you should be pleased to know that much of the outstanding work on that science was done by people in Environment Canada and the University of Victoria, who are on the University of Victoria campus. So the leading expert in the world on this, they now moved to headquarters in Toronto, but up until recently was at UVic. And so these people, the analysis is very clear. Humans are the cause, mainly. So how do we go to the future? That means we got to see, well, what are humans going to do? We can, as humans, imagine a whole variety of emission scenarios, and these are from the Intergovernmental Panel on Climate Change, a whole bunch of scenarios of global emissions. And with each of those, well, recognizing that we have had warming of 0.13, 0.16, for the next 20 to 40 years, we're going to see a warming rate of around 0.2 degrees Celsius. And unfortunately, this curve is artificial. It's basically saying if we stop putting all emissions in now, we went to zero, which is not going to happen, so ignore that one. But all of these various scenarios really don't start diverging after until about 2040. So that's because of this slow lag time. The climate system has built into it, in a sense, the input of greenhouse gas emissions of the last 100 years, and it will continue catching up because the ocean is still warming up. As we look to the end of the century, though, we could have a warming of more than, well, maybe almost 2 or like 3 or 4 degrees Celsius. And when you count the scientific uncertainty, we could be as much as 6 degrees warming or as low as a degree or so. So we have that to look forward to, and the human activities could make a big difference between, say, that scenario and that scenario. And as we all know, we don't live at the global average. Here we live in British Columbia, or you do, I live in Ontario. And what we see, though, is that basically speaking, the land masses warm more. So if the global average warming was 2.8 degrees Celsius, and that's what they might talk about internationally, most of the land will warm at 3.5. Most of Canada will warm between 3.5 and 5 degrees Celsius, and the Arctic will be warming at about 6 degrees Celsius. We are let's say, a relatively more impacted country, Canada, compared to the average around the world. We'll also see changes in things summer and winter. So for example, here in British Columbia, we'll have much warmer winters, and you'll have more precipitation during the winter time. In the summer, the expectation is that it will be really warm here over the western United States, but extending up into southern BC, so Cottage Country, Kelowna, etc. Probably even warmer again, relatively speaking, in the summertime. And of real concern, though, is the reduced amount of precipitation. Even though it varies in the north part of the province, you'll have more precip, but in where most people live, the southern interior, etc., and the western United States, a decreased amount of precipitation, which will aggravate already concerns about water. So we've got concerns about water, availability for sewage, the effects on agriculture, in this area particularly increased droughts, and unfortunately, because the rain, even though it goes down in the amount of rain when it comes, particularly in the winter time, will come as heavier deluges. It will be more flooding-like conditions. The impacts on forestry are also important. So, some of the things we worry about, clearly climate change, the prairies, the fires, etc. One of the things that people say, well, we worry about the cost of, you have in this province a carbon tax, and if I can put in a bit of politics and say, at least you do. You're leading the world in that way, at least partially. The British economist, Sir Nicholas Stern, did this major report, and what he pointed out was that if we don't take some action, the economic impacts by the middle of the century will be equivalent of losing globally at least 5% of GDP and perhaps as much as 20%. So there are major impacts around the world. So how do we respond to this? We can respond by reducing emissions, so we can change our emissions such that we end up, say, here or here rather than up here in terms of temperature change. But we can also do adaptation, and that's what we're talking about today. Adapting to the reality the climate is changing, reduce our vulnerability, and we need local to national strategies to do that. As a hazards person, we try to look at these things. We will have hazards. In this case, it's the increased numbers of storms, the floods, the droughts. But we also need to worry about vulnerability. And it's when we have an intersection of the hazard and a vulnerability is when we get a disaster. So just having a major storm doesn't mean you get a disaster. It's when you're vulnerable. And one of the roles of adaptation is to reduce our vulnerability. So what can we do as societies to reduce our vulnerability through adaptation strategies? And here are some of the things we are worried about. Well, I happen to have Victoria on this slide. The number of hot days in Victoria, which used to be around 2 per year, that's over 30 degrees Celsius, will probably, by the end of the century, be up to maybe 10 per summer. It's not a lot, but the reality is most people in Victoria are not accustomed to 30 degrees Celsius temperatures. We have had record-setting temperatures in August 2003 in Europe that resulted in 35,000 people dying, and that event will be by more or less every second summer by the middle of the century. So more hot days, virtually certain, more warm spells. We need to worry about better design of our structures in cities, more use of green space, shading, alignment of structures so that we recognize the heating effects, heat alerts and responses, medical advice, and often cleaner air. I just wanted to come to that a bit, because hot days are usually our smoggy days. And we've already seen this just in August 2008, the report from the Canadian Medical Association called No Breathing Room, just giving their estimates of the number of people who will die due to smog. And you can say, well, what's the relevance of that? Well, the relevance is two things. One is that the processes that result in air pollution are largely the same, let's say, industrial transportation processes that result in greenhouse gases. And the other thing is that the climate will make, for the same amount of smog, the same amount of emissions, will get more smog days. As we warm the climate, the chemistry, the atmospheric conditions change such that if you put